So it's now time to move on to the heart of the amplifier, and that consists of these two IRF 510s, this toroid here, T2, and this binocular toroid here, T3. So it's actually not a binocular core, it's actually two ferrite tubes, electrical tape together. Hans was able to save quite a, so his story goes, quite a bit of money in the kit to instead of using something like, well, let's have a look at, so this is an example of a binocular core that's of similar kind of power output handling, and these guys I believe are about, I think they're about $3 to $4 each, so these are quite expensive, these binocular cores, and when you can get away with just using a pair of ferrite tubes taped together, that's good for us all. So anyway, so T3 itself, it's got the two ferrite tubes together, so it acts as a binocular core. And the primary side of the core has 2 turns, and the secondary side has 3 turns. And this is wound with the thicker wire in the kit. I'm going to be using this 18 gauge wire here to wind it. I kind of like using the red wire in there, it's just me. Now with winding binocular cores, it's a bit tougher because it's hard. With a toroid, you can tell how many windings you've got. You can easily count them. Not so easy with a binocular core. All the windings are on the inside, and you can't really see what you're up to. So you really have to keep track of it. Now with 2 and 3 turns, it's not a big deal. It's easy to keep track of 2 turns. When you get up 8 and 9 turns in a binocular core, it becomes a bit harder to do. Now note, for a binocular core, a winding counts as the wire goes through both holes in the binocular core. So 1 turn is both wires through the center. Now once T3 is wound and installed, that goes on the board, and just showing you where that goes. Let's pan back a little bit. So the 3 turns are on the output side. So this is the output side here of the core. Let's just pass that. So you can see here it goes from the output through the low pass filter and then out through the RF out. And this is the input side. So the input side is the 2 turns, the output side is the 3 turns. And then once you've done that, you wind T2. And T2 is 10 turns bifilar on the other toroid core. So that's pretty straightforward. Fortunately, it's not trifilar because that was a pain to wind. And it is the wire on this is the 0.6 millimeter wire, so the thinner wire. So anyway, I'll get on with doing both of that, install, and then we'll test it. Okay, so here's the finished binocular core. As you can see, once you've cut the leads, if you haven't marked which is the 2 turn and which is the 3 turn, you've really got no way of figuring that out from looking at the outside. So anyway, that's the binocular core wound. I will move on next to the bifilar core. So here's the other core, the toroid core bifilar wound. Now it's the same job that we had with the trifilar core, is to basically remove the enamel from these wires here, untwist them, remove the enamel, and then figure out which of these goes with the ones over here. So that's to come next. Okay, so that's T2 wound and the end and the leads tinned. So what you want to do now is, so here's the 2 wires coming out one side of the toroid, and here's the 2 wires coming out the underneath of the toroid. You want to arrange these wires so that the diagonally opposite pairs have continuity. So in other words, these two wires have continuity, and these 2 wires have continuity. And you want to install it on the board just like that. So let's just bring the board into view here. Pan Going back a little bit. So on the board itself, you want to actually, these two wires come from the top. So again, these are the two wires that come out of the top side of the toroid. These are the two wires that come out of the bottom side of the toroid. And the diagonally opposite pairs have continuity. So this has continuity with this, and this has continuity with that. Now, Hans in his instructions asks you to mark them, and I think that's a fine way of doing it. I just like to get the orientation in the wires, and then it becomes an easy matter to get it into the board. Okay, so here's T2 installed with all except for one wire. The reason I did that is when I originally installed this, I put everything in, but then I realized that when you've done that, there's no way to test whether you've got the right wires in the right holes, because all of the wires of the toroid are all connected together. So both this side and so V plus comes in here and down here, and so when this is connected to V plus, this is connected to V plus, and then this is connected to V plus. So the whole of the toroid has continuity, so you can't check it. So if you leave this one out, however, you can actually check to see if you've got the right wires in the right holes. So let's just do that. So basically, the diagonally opposite wires should have connectivity, and they do, and the wires in parallel have no connectivity. So from here to here, or from here to here should have no connectivity. But this wire and this wire should have connectivity. And that's exactly what we're seeing. So now I've tested continuity. I can go ahead and install this wire back into its hole right here. And then basically that's transformer T2 done. So that's T2 installed. I'm kind of not particularly happy with the way it turned out. It doesn't kind of sit straight on the board, which is a bit of a pain. But anyway, just to show you how it's hard to test it when it's in circuit, these two will now have conductivity. So it's once you've got it in circuit, you can't really kind of validate whether you've got it right. So anyway, I'll move on next to the binocular core. Okay, so transformers T2 and T3 are installed together with capacitors C7 and C6. Time to do some quick continuity measurements to make sure everything's still okay. So it should have continuity between here and here. Let's just confirm that. Bear with me. So that's good, and obviously we'll have continuity here at the same time. They're connected. And then we should have continuity between this point here and this point here, which is actually ground. So that confirms that we have continuity all set. And what I'll move on to next is installing the IRF 510s. And there's a bit of fiddling around you have to do with the IRF 510s. You mount them on the underside of the board. And the reason you do that is because that's oriented towards where the heatsink goes. And the instructions are slightly different between the enclosure version and without the enclosure. I actually do have the enclosure, so I'll be showing that mechanism. And that's to come. So now we move on to the install of the IRF 510s. And it's worth reiterating at this point that I'm doing a lot of things out of order with the instructions that come with the kit. And that's mainly because it's fun to me to understand how this works. I like doing the module by module approach. And I have a lot of spares if I get it wrong. So what I'm going to do now is install the IRF 510s and then test the amplifier without installing the receive switch circuitry. So just to pan over to the schematic. So effectively what I'm going to do is I'm going to install the IRF 510s over here. I've got both of these transformers already installed. I've got the low pass filter installed. I have installed these two caps right here, so C15, C17. And obviously the diode and all the transmit circuitry was the first step, so that's all installed. And I've installed the RF out jack as well. So doing things a bit out of order, but you know, that's what I've been doing all along. So anyway, the process to install this is a bit complicated. Not complicated, but it's a bit fiddly, and it varies depending on whether you have the enclosure or whether you are just using the bare bones heat sinks that come with the kit. I happen to have the enclosure, so the instructions I'll be following is for that. So let's get started. So the first step, and here, what I've got here is the heat sink, the two heat sinks, and the top of the enclosure. And so step 0, if you will, is to take the two 6mm screws, so they're the shorter ones, and screw the heat sink onto the top of the enclosure. After you do that, the next step is to bend the leads of the IRF 510, and I'll zoom into this so you can actually see this. So you bend the leads of the IRF 510 upwards, and you really only have one chance to get this right because these leads are quite fragile. So if you bend it the wrong way, what will likely happen is when you try and bend it back again, they'll break. So once you've done that for both the IRF 510s, you then take the sill pads that are supplied here. Let me just move the heatsink into focus here. So you take the two heat sinks and you will align them with the holes that are just off-centered from the middle here. So what I've temporarily done is just stuck them down with tape. Now you've got to be careful. You don't want to tape over the top of the sill pads because they'll lose their they'll lose their heat conducting potential. So you really only want to cover the pads no more than 1 millimeter. And you want to line them up with the holes. When you press them against this part of the enclosure, they don't completely line up, but that's not to worry. So once you've done that, you turn the board over. Let me just get that out of the way. You turn the board over and then you install the two FETs with the heat sinks pointing upwards. And I'll pause at this point because now I've got to actually install this into here. Now that'll require a bit of setup. So now I've got the FETs installed. I've got the board here, and then what you do is you slide the board in this way. So this is the off center. The holes here are slightly more towards this end of the board, and that matches the setup of the IRF 510s. So you turn it over and then you slide the board into, there's actually two slots in the enclosure, just got to get it right. Bear with. There we go. Whoops, almost went too far then. I've got to go back. And then if you turn it over, you'll see that the sill pads and the RF 510s are aligned with these two holes here. So the next step is to take the 9mm screws, these are the longer ones, and put the plastic washer oriented this way, and then drop them into the holes near the FETs here. That's one side done. Let's get the other side done. I've actually screwed this up a few times practicing this on camera, so this is going to be a perfect take though. Oh my lord. Let's see if I can get it in there. Success. And then you take the remaining 6mm screws, insert them into the appropriate holes and screw them down. It is a bit fiddly, this part, and the screws keep dropping down into the enclosure, which was a bit of a pain. So when all the screws are down tight, now you have to test continuity, or lack thereof. Okay, so what do you want to make now? I want to make sure now is that there is no continuity between the middle pin of both of the IRF 510s and this screw here. So the sill pad is supposed to provide an insulating layer between the metal part of the IRF 510, which is actually connected to the drain. And if you don't, you'll effectively be shorting the drain to ground. So let's check continuity. Again, the middle pin, no continuity. Let's check continuity elsewhere. So there's no continuity there. And again, let's check continuity here. And just for giggles, let's check the continuity from the drain through to ground. No continuity there. Let's be careful here. Some of these connections are actually grounded. No continuity there. So that's the heat sink and the RF 510s installed. And the next step is to, now that you've got it all squared away, is to actually solder these guys in. Now, there's nothing to worry about. You can always, even after you've soldered this in, you can always remove this later on just by simply unscrewing here, and sliding the board out. So it's not as if this is a point of no return soldering here. And which is just as well, because as I mentioned before, I haven't installed any of the RF the receives switch circuitry. So anyway, that's the, I'll come back when the IRF 510s are installed and we'll take it from there. Okay, so that's all connected up. Let me just walk you through the test setup here. So here's the QCX here. Here's the control signal from the QCX. That's 5 volts on transmit and grounded on receive. Here is the power supply to the amplifier, and I've currently got that set to 25 volts. And then finally, the output from the the output from the QCX is going into the input of the amplifier, and then finally the output from the amplifier is going through this cable through to a 1.5 kilowatt dummy load that I have on here. So I don't expect to be tasking that too much. And then finally, I've got my oscilloscope set up to probe the output of the amplifier, just to see what kind of waveform and what the peak-to-peak value is. So let's go ahead and test that once or twice. So that's working. You can see if I pan up to the power supply, draws about 3.2 amps at 25 volts. And then finally, if we move over to the oscilloscope to actually see the waveform here, let me just get right close in there. You can see there's the signal. And we're looking at about 125 volts peak to peak. And that is, I've actually got a calc going over here. Bear with me. So I've got a calc going over here, so 125 volts. Oh, sorry, you can't even see that. So let's zoom in. I don't have a calculator here in the shop with me, so let's try 125 volts and see what the peak to peak and see what the power output is. And that's about 39 watts. So not 50 watts. I know the power was down a little bit on the QCX that I was doing. And I haven't tried to adjust R5. That's one of the things so the kit says when you're first starting this up, adjust resistor, the variable resistor R5 all the way counterclockwise before you start testing. So it is still all the way counterclockwise. Kind of a bit loath to move it to any further clockwise. I did it a little bit. It didn't seem to adjust the power output very much, so I thought, well, I'll just keep it at at that for the moment, and then I'll experiment a bit later. So that's the amplifier section of the kit working. What I have to do next is install the receive switch, and so I'll go ahead and do that, and then that'll be in the next video though. This is the amplifier done for this video. So a bit more testing and adjusting of trim pot R5, and the signal's now up around 135 volts peak to peak. So that's it's getting up 134 volts. So that's getting up towards 47, 48 watts, I think. So I'll probably stop adjusting R5. I think I'm probably pushing my luck on the ARF 510s, even though I've got plenty others, you know, at this stage. Yeah, that's up at 138 volts peak to peak. So quite happy with that.